Oops.
Just share the slides. We'll figure it out. That's not a problem.
Well, you know, I mean, the slides are I think I could try to explain those slides. Is it uploaded?
Yeah, it's actually broadcasting right now. So thank you for joining us. This is Chris Miller at Troy University. Here today with Vijay, one of our graduate computer science majors, as well as Dr. H. Is it all right if I call you Dr. H?
Sounds good.
We alluded to you as the mad computer scientist yesterday, but we're sure you have a lot of sanity, right?
Sometimes. Most of the time I do.
Yeah. Anyway, I'm perfectly sure he's a caring person, just as Vijay was discussing. Guys, if you have any questions, please go ahead and use the question and answer tab. We'll get to those at the end. I want to discuss a little bit about admissions first. If you have not made an application to Troy University, please go ahead and do that. It's troy.edu/enroll with 2 L's, the American spelling. So please go on over there, sign yourself up for a profile, start an application. If you need an application fee waiver, please let us know by commenting in the video box, and we'll get back with you on that. But let's go ahead and get started with the Google Hangout. Vijay, why don't you tell us a little bit about how you came to know Troy, what you feel like your experience has been so far in the program, and anything else you want to tell us about.
Thanks, Chris. Good morning, Doctor.
Good morning, Vijay.
And good morning, Chris. Thanks for making this Hangout meet and giving me an opportunity to talk. And I'm pretty excited that this is the first event which we're doing, and I'm making history along with you guys here. I've been working for about 15 years before I came to Troy with companies like HP, Dell, and what made me come here is I want to change my future by getting into software. I've been working in hardware all my life, and the most important thing that made me choose Troy was it's a public university, and it's one of the best international universities in the region, as well. It's most affordable university. Not to forget the weather in south is much warmer in comparison to north.
Yeah, quite a bit.
Yeah, these are the few factors which made me choose Troy. And the next part was talking about what my experiences here. It's been amazing. It's a pretty beautiful campus. Got a lot of recreational activities, as well as I got the best faculties and staff here who's helped me throughout my semester to keep myself up to the learning pace here. And in fact, as a matter of fact, I'm considering signing up for TSEs and computer science under the guidance of Dr. Hovsepian. He inspired me to do that. Most likely, I'll try and see if I can do that one. So.
Definitely can.
Yeah. So other things is this place has full of events. Throughout the week. Throughout the semester, you have some other events happening. Some of them hosted by international students, cultural organization, which keeps every weekly, or is it bi-weekly?
For the ISCO?
ISCO.
The one we went to. So the last one we went to was Indian Night. I think they do one a month. One a month right now.
And there's Computer Science Club, which happens I think there's a weekly meeting every Monday between 3 in the afternoon to.
Do you do that for that program?
Computer Science meeting.
The Computer Science Club, I think the writer actually is
Suman. Okay, Dr.
Suman.
Dr. Kumar.
And there is career services, which hosts a lot of meetings, and one of them is tonight having an interview skills to help students on achieving jobs. There are many more clubs and organizations which conduct events throughout the semester. I feel I'm going to be back in the future, coming back to future. That's how it feels when I'm here in Troy. And So my journey at Troy is gonna probably help me get to a better place in future. Because with signing up for some of the interesting, I'm here to learn some of the interesting subjects like artificial intelligence and cloud computing, and machine learning, of course, which is Dr. Hovsepian's favorite. Right. That's about me. If you have any questions, you can probably ask after Dr. Hovsepian's piece.
Yeah, let me ask you a quick question. You talked about career services. What do you imagine will happen after you're going to do the interview skills? But do you intend to use them for resume? I mean, you've already been in the field 15 years. You have a resume. What do you expect? I mean, do you have an on-campus job? Do you want to work for somebody in particular?
Okay, I forgot to mention about that one actually. If for the right candidate, I think it's pretty much easy to find a job, on-campus job here at Troy. I think it took me about a month to find a job, and I've seen some of the students who got it right within the fall they arrived at Troy. And as of this semester, I've also started working as a graduate assistant in an international department, which is pretty cool actually. That's one of the reasons I'm here sitting down talking to you people. Yeah, that's and how is it gonna help me on the interview skills? That's kind of an important thing, how to present yourself in an interview with people when you're attending an interview, and make sure how you sell better. I think that's the interview skills that are gonna help me do that.
Okay. Do you have a company you want to work for, a target, or a job?
I wish I could start my own company.
Start your own company. Hey, I like it. I like the sound of that. That's great. Do you want to add anything else?
That should be it for now.
Okay.
Unless you guys have some questions.
I'm going to flip it over to this big guy over here. You want to tell us, I love your backstory, firstly.
My backstory?
Do you think maybe you could touch on that for a second?
Okay, short version is I came to US, IO by the way. I came to US when I was 16. I came 16, I guess, when I was 17. I came as a foreign exchange student and stayed a year, went back, and I'm from Armenia originally. I went back to Armenia, actually lived in Moscow for a few months. And then I came back to US, being supported by an American family, generous American family. They're like my second family right now. And I stayed with them for 4 years for college, bachelor's in northern Wisconsin. And then I went to grad school, toiled there for a few years, and then I had 2 postdocs before coming to Troy. And been now at Troy for 3 years. Actually, this is beginning my 4.5 years, I guess. In May, I'll be ending my 4th year, and then up for 10-year review, and my 5th year. So time flies, I can tell you that. Time definitely flies. So let me just give you a few, I guess, give you an idea of our department a little bit. I think Vijay explained that we have a beautiful campus. The weather is perfect. People are lovely. You know, I think anyone would find that very quickly. And our department, I think, thrives on students like Vijay. You know, he's one of our better students, who is ambitious, who is bright, who has an idea of what he wants to do. And we have dedicated faculty. You know, there's not that many of us. But I'm anticipating bigger and bigger because our department in computer science is becoming so popular. And why is it becoming popular? So let me segue into that. Well, it is the field of the future. Computer science is going to mold so many other fields and areas. It's like what math was 200 years ago. It was a tool that scientists from physicists to psychologists to psychologists, I guess. Well, maybe more recently, right? But there's so many areas that use math to model different phenomena. And right now, it's you're seeing that with computer science. Everyone is using computer science to try to analyze data, to drive their devices, which is software and hardware, of course, going hand in hand to shape the future. So computer science is a very exciting field, and in the past, especially in the last 10 years, with bioinformatics becoming as important as it is, and again, small devices, embedded devices, artificial intelligence with self-driving cars. So we are going to be seeing some incredible transformations, I feel. And of course, I'd be ignoring the most important discovery of the last 50 years or so, or 40 years, I guess, from the start of the internet, the start of the web, and the networking that we, of course, now ties everyone together on this planet, and we take for granted. So I think in the next 100 years, we'll see something like that as well. We'll see something that revolutionizes the world, and then very quickly, people start taking it for granted, you know? And I think that's computer science. So it's also, however, a very challenging field. It's very nice. It's very rewarding, as I'm sure Vijay will tell you. You can definitely expect if you major in CS that you would, spend a lot of time delving very deep into the subject matter. And before I get into what I'm interested in, my area of expertise, I need to also say that what is computer science? To me, computer science, and I want to dispel this this idea that computer science is just about programming. It's easy to make that mistake. So the programming, which I'm sure you guys by the way, I'm talking to students who are not just computer scientists, right? So let me sort of have a more general view of that. So programming is how you create the various programs that run on your computer, or that are in fact run on any other device, such as running on the CPU of your car, or that may drive your television. So programs can be written at all levels, and you use this using programming languages. But computer science isn't just about writing programs. Computer science is about creating something. So computer science actually is a very creative field. It's kind of weird to think about, right? Creative field, isn't that art and music? How is computer science a creative field? It's creative because you create something that does something, whether it's something on your computer, again, as I said, something on a device. So you think of an idea that you want this program or this device that you will power with your software to do something interesting, do something exciting, do something fun. And that's when you use programming languages and your ability to write programs to implement that idea. And so it's a little bit like a sculptor. So I'm trying to be very philosophical, but it's like a little bit like a sculptor who envisions a sculpture that they would like to create in their mind. And that's the creative part. And then they go about using whatever tools they have, chisels and hammers and whatever, to shape that idea into an actual object. And so you wouldn't say that a sculptor is just someone who uses hammer and chisel, right? It's a creative field, and those become the tools that artists will use to create that. So we're not quite at that level of artistry, but still there's that idea that you think of something neat, and you can use the tools such as that you've learned in this program, in computer science program, to basically make those plans real. Especially with all the mobile computing and all the mobile platforms, people can create apps. Anyone can create apps. Anyone can make an app that does something and can change their life and the life of people around them. So I think it's an exciting field, I think.
As a non-computer science guy, what's the analogy? What are the hammers and chisels that I'd need if I were computer science? If I were considering computer science.
So some of them are very low level, which is why sometimes people start computer science. They think, I'm not getting this creative. If somebody started with like, that guy started creative, I'm not getting this. Because at that low level, you do have to learn you have to get almost like a sculptor learning the muscle memory to chisel and to hammer. At that level of detail, they're not really thinking of the creative part. And once you get trained into using the tools.
What tools?
This would be software, sort of, for example, programming, using different languages like C++, Java, Python, Java being very popular, of course. right? C#, whatever those languages may be, and also learning the various software development skills and being able to do that. Also, very important is learning algorithms. So algorithms are, I don't know if you guys are familiar with that term, of course, is something that's very mathematical. It started as a mathematical concept about solving a very complex task. By application of sequence of a well-ordered sequence of simple steps, simple instructions, simple things. But together, those simple things in a specific sequence accomplishes something extremely fascinating, exciting, or complex. And so you have to learn algorithms, which is why I have a course dedicated to that. You learn, of course, a whole bunch of languages. Again, those become like your chisel and hammer. You learn also many other concepts from artificial intelligence and learning the algorithms needed for that, to operating systems. And so all of that makes you a well-rounded a person who is primed to do what? To put their creative ideas into reality. And so, and of course, throughout these 4 years, you would have opportunity to already create things. So there's a applied class for undergraduates where they get to think of a web application, and they get to try to create a web application in 1 semester. For our graduate students, of course, there's so much more, there's even way more opportunity than that to do that creative part. So there's graduate courses that are project-based, where our graduate students can get into groups and will solve some very interesting tasks and problems, I hope. So in my class, I have a computer vision class, and Vijay is in that. So we have some, I hope our students will do some, and I'm sure they will create some interesting applications of computer vision, which is, computer vision is this field that says, can I use a computer to try to do what my eyes and my brain does, which is take in a picture or a video, analyze that, label what it's seeing, understand the scenery. So all of that is something that you can try to do with computational methods using, again, so that's the creative part, and then you actually have to program that yourself. And so that's where the sleepless nights happen. Okay, so this is something that you can think of an idea, and this is something that I think is very interesting. Sometimes I get into that as well. You almost feel like the field, you can just snap your fingers and your idea will come to life. It's not so. You think the thing of an idea within bounds of what's reasonable, even in technology, but also pushing the boundaries. And when you do, then you spend days, weeks, months. I've spent a few years on a project, and then finally it comes to fruition. And so that's the thing. But then, just like I said, sculptor has to spend a lot of time to try to sculpt that idea. And so,
So it's not all zeros and ones, but it's also not Instagram.
No, exactly.
Okay.
But
Somewhere in the middle.
Instagram, by the way, was another creative idea somebody had.
Sure.
Let's create a web app where people put, so again, I just feel it's a field that's going to be very exciting. And again, thank you for this opportunity to speak. But it's not the only major out there. But if you do like to tinker with things, you like to understand what happens inside of a computer, what happens, how this program works, and you're willing to really get into that world, I'd certainly recommend computer science to you. So.
That's great. Now I know you prepared some slides to talk a little more, maybe about your visual research. Or
So my area of expertise within computer science is computer science, such a huge field. There's so much in there. My specific area is is machine learning and data mining, and my previous postdocs have been in those areas, and also electronic health, which kind of is more of an applied area in which I would apply these techniques, machine learning and data mining techniques. I did have a few slides. There's a couple of them are like word clouds. I could sort of maybe we could use those too.
All right, so I'm going to share Dr. Hovsepian's slides, and hopefully we don't lose anything here. Wait a minute, that's not what I want. I want this one to come up.
Okay.
I'm going to try to make this share. Obviously, I'm not a computer science major. Well, there we go. I think we got it. Hopefully, everyone can see that. I think there's only a few people with us right now, but it does say there at the bottom that we are sharing that doc, so go right ahead.
Awesome. Great. Well, hope it's not, and this is in computer science, you do see a lot of these kinds of figures because, of course, figures help us to understand concepts and to tie them together. So this is just kind of this is not my figure, by the way. I should mention this. I didn't create this. I used information publicly available. So this is a figure that just quickly tells you sort of aspects of data mining. So in data mining, you have data, right? And this data might have been collected via sensors, might have been collected by a polling that people did. Maybe you got this data from internet. So this data is very complex. There's a lot of different variables and a lot of different information that is described by this data. But what we want to do in data mining is try to understand this data, trying to extract from this data some source of knowledge and understand the phenomena that was responsible for generating this data. And so in data mining we use certain techniques to model data. And you can see there it says create model. So you have this idea that you want to first gather the data, and you can see that. Notice there's a loop happens. In red, it's called problem definition. One way to think of that could be as a phenomena that could generate this data. Take an example: weather patterns, right? So we can say there's a general phenomenon, physical phenomenon that generates temperatures around the world, right? And wind speeds around the world. And so you collect this data, and you prepare this data. You go through all this kind of tasks of preparing data, cleaning the data, and then we want to model this data. In other words, we want to create a model which can generate that data in a virtual or simulated environment. So you have the real data that came from a real world, but then we want to create a model that would explain that data, or at the very least be able to generate that data and simulate that data. Why would we want to do that? Because once you have a model, you can answer a lot of questions about the data, right? If your model is very good, you hope it's good, and you try to create a model that is good, it's not going to be perfect, of course, because it's only a model of real phenomena. But if it is pretty good, you can look at it, you can answer a lot of very interesting questions, fundamental questions about that data, and therefore about the phenomena that you want to study. And so data mining, again, has all these techniques to extract patterns, structure, and sources of information from data, which otherwise is so much of it that we get lost, and we get the human mind can get lost in the sheer number of various different pieces of information that are in this data. So, but techniques can be used. Formal techniques, computational techniques can be used to create models, evaluate models, extract information from models, and so forth. So
this is how the predictive analytics comes about.
Predictive
right?
analytics, exactly. So predictive analytics says, if once I have data, I can build that model. I can build a model of that data, and I can use that model to extrapolate into the future and predict or infer, is how we call it in machine learning, infer things that I don't know from the data that I do know. So your data is all that, which is true, right? Your data represents what you're able to collect easily, not so costly to collect that data. This may be things like video cameras, microphones, asking simple questions, right? And so we can collect these things easily. But what we cannot do is collect things that are hidden, right? Things that are somehow responsible for this data. And so can I infer the things that I don't know or that are difficult to get from the things that are easy to get? And that inference happens with the help of such models. So again, so you build models, and now that part of data mining, building models, that is made possible by machine learning, which is kind of, or statistics. So machine learning statistics sort of are two terms which are quite close, which is the idea of using an algorithm to learn from data to solve some task. Okay, so a core of machine learning is models, machine learning models. That, I don't know if you guys have heard terms like Bayesian networks. In Bayesian networks, for example, is a fascinating type of machine learning model where you have certain things about life that you have collected, certain, let's say, we call them, let's say, variables. Or you can say facts. And so these facts are related to each other, right? Some facts are precipitating other facts. In other words, one event occurs, and that event can cause another event. And so these events are related, right? One event depends on another event, or one event drives another event. So you can create a model using this technique, Bayesian networks, that essentially describe these relationships between these events. And then you can take this model and you can test it on real data. And if this model fits this real data, you can use this model to understand very interesting things about your data that you've been seeing. So you can use it to explain, for example, whether, what are the factors, what are the causes for a person to fall, for example. One of the data sets, I have a student working on this, there's a data set collected from elderly retired people living in different situations, and some live in assisted homes, some live in their own homes. And people have collected over 1,000 different questions or answers to 1,000 different questions related to their health, related to their conditions. One of the questions is whether they have fallen in the last 30 days, because falling among old people is very dangerous. Can we understand, based on the other variables that we know about their life, why they may have fallen? And so if you can build such models that try to predict whether a person has fallen or not from the other data, you can then understand the causes for a person to fall. And I say this again, this is a creative thought, very difficult problem turns out to be. So my student has worked very hard, and it's a very challenging problem, as you'd imagine. So some of the more interesting problems that we delve in are very challenging. But so that's really the idea of machine learning. I guess, yeah, so machine learning is just one more slide I have, but it's a little more, I know it's not a very exciting slide. It's a very simple slide. So this is an idea of one type of machine learning, which it's called supervised machine learning. And what's the idea of supervised machine learning? So let's say, again, I have a bunch of data. One classic example of this would be if, let's say, I have a database of people, and I have, for every person, I collected a lot of different factors, a lot of different variables, such as their age, their income level, where they live, how many children they have, are they married, are they male, female. So a lot of different demographic variables. And I want to be able to label or classify each person into one of several classes. So this would be, for example, this is because this stuff is sometimes important, again, that label, that class, and I know it sounds bad in terms of it's not good to label people, but this is an idea of trying to understand some of the hidden characteristics of each person. And for example, you can use it to understand, is this person going to require, I don't know, insurance, or is this person going to succeed as an employee, right? So you can answer a lot of different questions that on the face of it are hard to answer. How can I infer from these things what category this person falls into? This is why you use machine learning. So what you do is you collect the data set for which you have that information, for which you know, for these 100 people, I do know what category they fall into. And so you take these 100 people, and using these 100 people for which you have both their, again, the database of different variables, right? And you know their categories that they fall into. And using this data, you can build a model, which I described. And this model then can be used to infer their category for other new people. So you build this model, and then other people come in for which you don't know the category they're in. And can I infer their category, can I infer their class of their label from just their database of demographic variables? And so if you can, you have just been able to almost have an oracle. you almost have something that gives you magically something you didn't know, or at least it guesses or infers that thing that you did not know from information that you can collect. So that's it. That's the only slide. That's the only other slide. I mean, so this is kind of shows you that you can use that data, build a model, and then use that model to infer different things from other data. So so machine learning, you know, it's in few words, I guess, kind of that's one application of machine learning.
Okay, let's see if you have any questions at any time, you can use the group chat. We're also taking the Q&A is on as well. I do see we have a question about general admission. We'll go ahead and leave that alone. But if you have questions about machine learning, if you want to talk about the visual programming that's going on.
Computer vision, yeah.
If you have questions about that, this is the time to ask those questions, because you know we really want students to understand that it's not just about coming to the U.S., which we know there's a lot of challenges there. It's not just about paying tuition, but it's about what you get out of it. And this is your chance to ask questions to the faculty member who's right here. You can ask a student who's going through it right now. But as far as general admission questions, we'll take that later. I'm really interested in this project that Vijay keeps telling me about when we're off camera, about the visual programming or visual
Computer vision.
Computer vision. Sorry, see, I'm not a very technical computer guy, so I don't know exactly what that means. But is it something similar to like when Facebook suggests to me, do you want to tag this person because they use the visual recognition?
They did facial recognition right there. That's one classic application of computer vision. Okay. You can go so much further than that. You can have obviously object recognition that is not just faces, and also in that the application of doing facial recognition when the face is looking straight on is actually very simple. But now, can you, and Facebook does, I think, goes beyond that a little bit, where they can actually detect faces that are oriented differently, but that's a much harder problem. So if you only classify faces that are looking dead on, that's quite simple, because your features are always the same, they're always, but now can you classify or can you identify that these are the same two people, and one person is looking to the side, the profile, and one person is looking dead on? That's a much harder problem. There's so much more computational depth to understanding that these are the same features, they have the same eye, the same brows, but they have a different orientation. So that's facial recognition is a classic problem. But there's so much more in computer vision that I think is fascinating. I don't know if you talk about.
Yeah, you wanna? One of them. What I've seen is using a camera to recognize how old the person is.
How old someone is? They can literally tell how the age.
Awesome.
You're working on this in your class.
No, it's already. I think it's already out
Okay.
there. You know, it works to a certain extent. It depends on the, like Doctor said. You know, it's more dependent on the data set what we have, because that's how you recognize and match the pattern and say if he's 30 years old or she is 40 years old, depending on the data. So
that could predict the age-related diseases that even if you took it a step further.
could be. Yeah, that's a potential.
They do a lot of amazing things. There was a video. I mean, one of if I can sort of remember some of the more exciting sort of applications that I remember. One of the things I remember, this is quite a difficult problem, but there was a talk I went to, and they used motion recognition, and so this is more like video, to try to diagnose in small children autism. One of the things they were saying is that autism isn't something that you can do a test for. Instead, it takes behavioral scientists and behavioral psychologists, child psychologists, to spending time to basically find at early age, a young age, to find the cues that would of autism. But so it takes a human practitioner, it takes a child psychologist to make that diagnosis. But there are certain things that they notice, that they recognize in an autistic child, which is this non-engagement, for example, with toys. So a child is not autism. If you throw them let's say a little a ball and you engage them, they are engaged by your wanting to play with them. Children who have autism, unfortunately, they do not have that engagement. So that's something that you could have a camera that records that video, and using computational techniques, you can do this. It's amazing things that they can recognize that two people are looking at each other, and so they can detect an event of engagement. So you analyze the video, the computer program analyzes the video, it detects events of engagement.
Okay.
Again, because that's something that we can do, right? I can recognize when two people are engaged. And again, there's certain markers, there's certain things that I notice when I think two people are engaging, right? They're looking at each other. There is a kind of a transfer of hand motions or transfer of body language, right? So there's certain things that you notice that you think these two people are engaging. And so you can build a model of that. You can build a model that is able to do that as well. And if it sees that that's not happening, then that could be a kind of a basis for making that automated diagnosis that a machine could do. So that's sort of, I think, is very, very interesting. It's certainly very challenging, but I think that is exciting sort of application. But again, there's so many things. Again, analyzing posture, analyzing different gestures and body language. Even doing hand, But one thing would be good is, can you have a computer vision algorithm that can read sign language? I mean, I think that would be pretty exciting, right?
Yeah.
If you did that, then you wouldn't.
It's so funny, we're right down the hall from the sign language
Really?
lab.
Cool,
So,
cool,
yeah,
cool,
it's
yeah.
really interesting that you say that. Which is something that could be static, but also in motion.
Right. Exactly. Because I mean, you want to, because if you took pictures, you would have to, so you have to take almost like many pictures and try to understand them. So I don't know how difficult that problem would be. And but I'm only just starting computer vision myself. I want to make sure my area is machine learning and data mining, but computer vision has a lot of elements of machine learning. So I'm still learning computer vision as this guy's last class. Actually, yesterday was one of my classes, and it was very interesting. But yeah, it's an interesting field. But other applications could be cars that drive themselves. There was one interesting thing I remember. In fact, it was a paper that was published in a pretty good conference. This researchers did this thing where they had a camera that looked out both the person, that sort of had a forward-facing camera that looked at the driver, and a camera that looked out onto the road. And that camera would try to detect cars. And you can do that. Just like with faces, you can detect cars, which is awesome, right? And if it noticed that a car, also try to infer the speed of the car, which you can do because as you're recording the car in small and big, you can try to, again, this is machine learning. Can I infer something that I don't know? I don't know what the speed of the car ahead of me is. But can I infer that? Can I guess what that is by seeing images of the car? So the image doesn't change within 2 seconds, right? The size of the image doesn't change. I can infer that its speed is about the same as my speed, right?
Yeah.
Because it can detect, because it knows the speed of the car it's in, right, by GPS. But if that image changes, then you can infer how much faster the car is going compared to me, and you can guess what that speed is. So then it detects the speed of the car ahead of you, and then the forward-facing camera that this person used was to detect what the person is looking down right now, whether the gaze is not on the road. So to do that, it had to identify the eyes. If it noticed that the eyes' gaze is not on the road, so to do that again, that's computer vision. Let's not just recognize a face. Can I actually identify and mark? It's called registration problem. Can I register on this face where the eyes are, where the mouth is, where the nose is, where the ear is? Okay, so now you can identify if the gaze is different, and it's like, look, if your gaze is not looking at the road, if the car ahead of me is the speed is slow, and you're about to ram into it, they could play a little sound and try to alert you to look on the road. So you see, somebody came up with that creative idea, and then they thought, and so sometimes it's challenging. I have also some ideas that I think are interesting. Can it be done? I don't know. Yeah. Until you have dedicated students that as a faculty, students like Vijay, you guys they're very valuable, very precious to any faculty, because you want students who are willing to work on interesting ideas and willing to come up with their own ideas, but willing to certainly to dedicate themselves to interesting ideas. Because without that labor, without working, you cannot put a cool idea into it. Just like a sculptor can think of a beautiful sculpture, unless they're willing to sit there and work, that sculpture won't come to life. And so this is the thing about this field.
So what's your big idea for your company?
Good question.
I'm going to figure it out over the course of time. I mean, I've got too many of them.
Too many.
Yeah,
Too many ideas.
Too many ideas.
That's awesome.
So what do you do with all of them? You just leave them in your head, or you write them down?
And some of them go into paper and then stays in the computer.
It stays in the computer.
Until I find out the best match which is more suitable to getting to a point of putting that into practice.
Okay. Okay.
Well, I think I think that it's good that you're writing them down, and so and revisiting them in your mind, especially as you mature more as a computer scientist, you might find some idea that you thought was not doable. All of a sudden, hey, wait a minute, never mind. I think it can be done. So I think again, I think the more ideas you have, the more creative you think of your abilities and your ambitions, the more creative you are with your ambitions. I think the better it is, because if you are too creative, you can think of a sci-fi kind of idea, which you just don't have the technology for. But within what you can, I think that's great that you're doing that.
As we were talking, we were just thinking about it's like some of the things what you're talking about, autism. It's like you're actually putting collective data of all the doctors across the world into a computer, which can probably judge better than the doctor. Because as an individual, if I were to be a doctor, I would treat the patient in a different way, and then somebody else would have found a different solution. And so you put it all together in one computer, which can do that job. All the discrete data into data, which makes it solve the problem much easier.
I read an article. There's a prize called the X Prize. Have you heard about the X Prize?
The X Prize.
It's what caused the self-autonomous driving cars.
Okay,
there was a prize that they had drive from LA to New York, right? Well, I think that is the next X Prize. Actually, is the self-diagnosis in a handheld, and I think they're getting closer. And maybe you'll see that at some conference very soon, and maybe you take a couple graduate students with you, and maybe that's something you guys who are watching this right now will be a part of in the future. You mentioned bioinformatics. Honestly, the idea that you could walk up to a kiosk, give a sample of your blood, and find out what's wrong with you without having to sit in line at the waiting room for 30, an hour, 2 days, whatever it is, no matter what part of the world you're in, and get that diagnosis, and then have it confirmed by a doctor who, if they can't meet you right there, they meet you virtually. That's the way the future is going to be, because right now there's just a shrinking workforce in throughout the entire world. We're just overpopulated. But I just think that if you want to be in computer science, there's a whole lot of opportunities out there. If you're even curious about computer science, try some of these things. Do you recommend a site where people can kind of play around with things at all? Or is there somewhere on maybe one of your web pages they can look at?
Well, I think I don't know if this is right now there's a whole many sources of online classes which are more centralized, are more specific to some area, to some topic. But I think internet right now is so much information I can suggest some specific websites for data mining or machine learning. There's one place that it contains data that you can use to try to do some of these things, and people post data. Maybe even X-Prize is there. It's called Kaggle.com. Maybe you're familiar, but it's Kaggle.com. That's basically a website where companies or even individuals post their data, and they want people and other participants and other people who are researchers and people who are willing to play with that data to try to answer some of these machine learning or data mining questions. But I would just go and I would just just go to Wikipedia. Also, again, I hope it's okay for one institution to suggest these online courses. But you guys know Coursera, I'm sure. COURSERA, right? Coursera. So it is not as expensive as actually getting a 4-year degree. So certainly, I would not say, if you have the opportunity, I would still say coming to institution and getting a 4-year degree where you have access to faculty and students certainly is still, I think, better, at least right now. Who knows, maybe in 100 years it'll be different. But what those different websites are doing is they're filling the gap. They're filling sort of for students to have extra sort of resources. So I would certainly look at the web, and I would read on machine learning, data mining, find online videos on YouTube where people describe this. There's also a really great website I like, videolectures.net, one word, videolectures.net, where you can read lectures by some really big names in the field describing some of these things. And just again, if you want to get inspired, you can look online, and I'm sure you would. And again, but then you'd be inspired, and then you would commit yourself, and then you would get to start your journey. And such as like Vijay, I started this journey. By the way, if I had a question for you, so compared, I mean, I know you just started a few courses. So far, what do you like about software that you think, or because I always think that whether people, what they like about hardware, and then how is software world different? What's one difference that you've noticed between dealing with software and learning about software methods versus hardware methods?
Okay, I mean, all my life, I think the 15 years is more dedicated to hardware.
Right, exactly.
Software actually gives that aspect of, I think it's more of a higher level of thinking, putting computer into the domain of user people than hardware. Hardware is more just a machine which can think about zeros and ones, nothing more than that. I mean, it probably can't even think without the software.
Right.
So yeah, that's what I'm learning here, and then it's going beyond the step of just knowing hardware, because the kind of knowledge what I have in hardware is actually helping me understand how it actually works in the background.
Right.
When you write a piece of code,
right,
and have it working to explore solutions for the whole of human betterment.
Yeah. But it's very right. You said sometimes software computer scientists say, "Well, I just operate in a software field. I don't know, or I don't care how the hardware works."
Who cares about hardware?
What I like is that you have both views. You know the actual chips, you know the semiconductors, and the hardware part, how these things flow together. But a lot of software, a lot of my students, for example, they don't know what's inside. I mean, we have a class dedicated to computer systems and computer organization that tries to discuss that, but still, it's not at the level of someone who's actually working at it. So,
yeah.
But it's nice to have, it helps both sides. Yeah.
So many of you who watch this video probably have tinkered with computers and are considering Troy. I'm going to ask you guys, if you agree to let me share your email, please point above your head in 3, 2, 1. All right. So we're going to share our emails above our heads when I edit this video. And
I wasn't sure what this was actually. No, I was like,
I'm going to put an
annotation.
annotation. Now I got to make the annotation fly around above your head since you're moving. But yeah, thank you guys for coming. We're going to cut it just a minute short. And again, this is about the computer science program at Troy University. It's 2016. Who knows what's going to happen in 2016, 2017 academic year. If you are interested in applying at all, please visit www.troy.edu/enroll with 2 L's. You can fill in your profile, fill out your application in about 10 minutes. We do not require an application fee up front. If you need a waiver of any kind for that, or you find some resistance, please feel free to contact us or drop a comment. We do get the alerts when we do that. I think I'm just going to say, for Vijay, for Dr. H, and for myself, thank you so much for coming. And we're going to switch over a little bit to the admissions questions now. And thanks, guys, for coming in. I think we're going to close the GoToMeeting call as well if anyone's listening there. Thank you for joining us. Thank you so much, guys. Really appreciate it.
Thanks, Chris, and good luck, everyone, and thank you for your attention.
Yeah. Hope to see you soon here. It's a good student community as well here. I mean, we help each other in the course of learning and then learn a lot of things. Thank you. Thank you for your time.
Yeah, and just to piggyback off of what Vijay is talking about, we actually have about 1,100 international students now. Did you know that?
Wow.
Yeah, on 7,500 students on the campus. Now, if you go and look at U.S. News World Report's going to say that Troy has 18,000 students and that has this ratio and this ranking and these things, but you really don't know about Troy from a non-online aspect until you come to the campus. It's one of the oldest campuses. We're probably the third oldest university in Alabama. We're not a land-grant university. We're actually started as a teacher's college, and we really love international students. We are Alabama's international university. We have teaching sites in Vietnam and Malaysia as well. We've had them in all different countries as well, Germany, Japan, Korea, and Saudi Arabia at one point. You can even go to Hawaii and study. We have a very far reach. A lot of it is because we've been in distance learning, and that would not be possible without some of the computer science studies that have happened here at Troy. And I know it's been 25 years.
I just came back.
I've only been here for 4 years, but
that's the way
you
brought it full circle back to computer
back to computer science, of course. So use your computer science. Go online and to troy.edu/enroll with 2 L's. Do your application there. Again, guys, my name is Chris Miller, and I'm going to let you know that it takes about 72 hours for us to get all your documents, have everything submitted, and get to an evaluation process. We do accept 3-year degrees. We do look at the core curriculums of that. We're looking for higher GPAs, less backlogs if you're coming from the British system or something similar to the British system. The GPA that we're looking for is somewhere in between a 75 to an 80 if you're looking for a graduate program. Undergraduates, I'll talk to you more specifically if you'll email me. Again, I'll put the emails in the comments down below. Thanks for stopping by, and have a good day.